Okay, so last time we started finding area under the curve is the net area, right? And using the limits. So today, after we go over a few properties, and then we will learn how to do this faster without using the sigma and limit, okay? So just like derivative, right? We have property that we could use. And then in the derivative, the main focus was on slope of the tangent line. And in this section is focusing on the area. Okay, so we are going to use the area under the curve to explain these properties. Okay, so the first one, right, just like last time when we talked about this notation, right, the integral sign, whatever that's after the integral sign, right? Like over here, the yellow highlighted, right? The x squared minus 4, that's the function of the graph, right? And then the answer that you get will be the net area between that function and the x-axis, okay? So our first one, here the function is a constant, right? So you can think of it as y equal to 5, okay? And that will be an example, right? So we are integrating from A to B. So let's say 1 to 3. I'm just making up an example, right? Of 5 dx. So then this part is the f of x. This part is the first one is the height, right? And then this part is the base, right? Base times height give you the rectangle, right? So how do we draw y equal to 5? Joan, what does it look like?
Just a straight line at 5.
And vertical, horizontal, which way?
Horizontal.
Yep, okay, so let's draw that out. So at 5, horizontal line, right? And then ask you to go from 1 to 3, right? The boundaries are 1 to 3. So those are the A and B, the interval, right? So we put 1, 2, 3. So the area between the function and the x-axis, right? Pretty straightforward, will be this one. So that's the shape of a rectangle, right? So area of rectangle, we do base times height. Height is always 5. So 5 times 3 minus 1. Okay, so that's why we get this formula. C times B minus A, which is 5 times 3 minus 1. Okay, pretty straightforward. So this one is a rectangle, right? And then the next one is when you see the boundaries, they have the same numbers on the interval, right? So that means there's no base. Okay, so the function can be anything, right? It could be a wave, doesn't matter, f of x. And then we want to find the net area from A to A. So there's no gap, right? So that's why there's no area at all, right? So pretty easy to understand, right? Next one is integrating from A to B, and I could break it up into A to C and then C to B. But you need to make sure the C is between A and B. So an example will be, here's a function, right? F of x. We want to find A to B, but then there's a C in between, right? So A to B, this whole area, the red one, will equal to the green one plus the purple one. Okay, so the purple one is C to B, right? The second integral. And then A to C is the green one, right? And then add together, give you the red one. Okay, I think with color, right, much easier to see it. Any questions so far? Okay, now the next one is more difficult to draw, right? It says that if you swap the interval, right? Like 1 to 3, and then you do 3 to 1, then the answer, you need to add a negative sign, okay? So instead of drawing the picture, right, because basically it's the same picture, right? So instead of drawing picture, I'm gonna show show it that it's true using like algebras, okay? So let's say we do a to b here, f of x, and then I'm going to write it as equal to, okay, let me erase this part. I can write it as a to b. Okay, I can write it as, let me erase this, okay? I'm going to write it, start with a to a. Because we know a to a from number 2 equals to 0, right? Because there's no area. And then using number 3, I can write it as a to b, and then plus b to a again. Take a look at the way I write it compared to number 3, right? You can break it apart if the C and C, look at number 3 right now. C and C are connected, right? In this case, I'm using B connects to B, right? So still work. And then the B, right? The number that you try to connect has to be between A to B or equal to it. So it's okay to be the same.
Jason,
Yeah,
wait, I have a question about the A to B and the B to A thing.
yeah.
Wait, so A to B is one area, and then B to A is like you're going backwards, so it's negative?
It will become negative, but right now we want to show that it will be negative, right?
Wait, no, I meant like, because you have F, or like the A to A is equal to A to B plus B to A, right?
Yeah.
Is like one of them, is one of the A to B or B to A like a negative number?
Doesn't have to be. It can be any number.
Oh.
The values of A and B, are they negative? Is that what you mean?
No, I meant like when you add up the two of them, like one of the values of the entire thing will be negative, right?
Yeah, yeah.
Oh, okay. Yeah, thank you.
Okay. So the way I write this out, okay? Right now, this part, the part I underline with the red line, okay, is using number 3. Okay. In number 3, we had A to B to start with. So all I did is I replace the B with the A, right? And then in the green part is A to C. So C, I can choose it to be anything. I chose it to be the value B, okay? So it will work as long as the two little red circles are the same, okay? So for example, like if I have -1 to 5 plus 5 to 1, sorry, 5 to 7, 5 to, right? So as long as the top end and the lower end are the same, then I can connect together, right? Write it as -1 to 7. Okay, so right now what's happening is instead of 7, I have -1. So it will end up as -1 to -1. All right, so that's what I'm writing out. Okay, so because they add up together equals to A, so it has to equal to 0 because there's no change in the boundary. So in order for them to add up to 0, then these two must be negative of each other, right? Equal to negative of B to A. Otherwise, they cannot add up to 0, okay? So that's just to show you why when you flip the boundaries of the interval, you need to add a negative sign. Okay, next one is the constant. Okay, so it's saying the constant can be pulled outside, right? There's a constant C, right, over there. You can pull it outside. So, for example, let's use a straight line. Okay, it will be easier to understand. So let's say the function is 5. Okay, let's use y equal x. Okay, will be easier. And then the other one is, so if I have, if I multiply by a constant, it'll be 2x. Okay, so let's draw this out. And then let's use boundary of 0 to 3 then. Okay, so one of them is this one. Okay, that's the first one. And then I'm gonna draw the red one with a constant outside. Okay, one has a constant inside, the other one has constant outside. All right. So for the first one, the slope is 2, right? So 1, 2, and then 1, 2, 3, 2, 3, 4, 5, 6. So the area will be this one. So for the blue one, it will look like this, right? So area for this is what? Can you calculate the area of this one, Leon?
It would be 9.
9, right? Very good. Base times height, right? 3 times 6 divided by 2, right? So this is 9. Let's put that, let's write it on the side. So this is equal to 9, okay? Now let's draw the red one. Red one is saying I want to find under the y equal x first, okay? So it'll be here, 1, 2, 3. It'll be this one. Okay, so the area for that one will be 3 times 3 divided by 2. So that's 4.9, right? 4.9 times 2.
Wait, 4.5, right?
4 times, yes, 4.5, thank
Oh,
you.
okay.
4.5 times 2, so that's also a 9, right? So that's showing you that you can pull out the constant, okay? Because you can think of it as every part is getting double, right? You think about hairlines, right? If you think of the red one, the area of the red one is made up by a lot of vertical lines. Each represents tiny rectangles, right? The area for the red. So if you double that, it's making it 2 times longer, right? So you can either double it first or double it later. It doesn't change the area, right? Next one is add and subtract. Okay, add and subtract is saying you can split. We'll just do the adding, okay? So let's say we draw f of x plus g of x. Okay, or you use straight line, easier to show. Okay, so I have f of x is this one then. Okay, so up to here's a, here's b. Okay, and then red one, let's use a horizontal line. Okay, this is not really a proof, but just to help you understand what it means. Okay, so if I want to find the area of those two add together, right? F of x plus g of x. When you add these two functions together, basically it raises up the you add up all the y's, right? F of x is like the y value, so the whole thing just adds up to become higher goes there, right? And then the red one is down here, right? Adding up the two areas. Right, so this one. Okay, so that's what it means. Okay, you can either you add it up separately or add the function first and then find the area underneath. Right, so this graph, the third graph that we had is the add together first and get the area, right? And then the top two is find the area separately and add them up. Okay, it will give you the same answer. So these are just some demonstration, right? What each property, and then with a picture, it can help you remember, right? To use it whenever possible. Okay, so let's look at what kind of question they will ask. Okay, using these property, right? So let's look at next page. So the first one, right? It tells you to use the properties of definite integral, right? What we saw just now is called definite integrals. To simplify. Simplify means make it shorter, right? Into a single integral. Single means just one, right? You just want to have one integral sign. So I'll demonstrate one, okay? And then you can think about question B. So for this one, you have -2 to 5, area from -2 to 5 under f of x. And you want to subtract this with -2 to 0, okay? So what we see here is there's something the same, right? But then if you want to use number 3, the same value, it should be one at the top, one at the bottom, right? So what we could do is we need to flip it, okay? We can, what can we do?
Wait, can we make the second one, like you multiply that one by -1, so it becomes plus instead?
Okay, so let's say we flip the second one. So first one, will keep it the same. And then using, what was that? Number 4, right? Number 4, if you flip the boundaries, you need to add a negative sign. So become plus. Right? And then now it sort of connects, right? So I'm going to swap the order, right? So you can see better. 0 to -2 plus -2 to 5. Okay, so these two, they connect together.
Wait, Jason, I have a question.
Yeah.
Because 0 to -2, you're going like kind of backwards, right?
Backwards, yeah.
And then -2 to 5, you're going forwards, right?
Forwards, yes.
So can't we just get rid of the 0 to -2? Because the -2 to 5 already has like -2 to 0 in between.
But then 0 to -2 is backwards, so the value for that will be a negative.
Oh, okay.
-2 to 0. So,
Okay.
so it's better, right? Usually it makes more sense for us to have smaller number at the bottom, right?
Yeah.
Instead of a smaller number at the top. So how about this? Let's flip the first one so it makes more sense, right? So we have negative and then -2 to 0, right? So now it makes more sense. And then I'm going to break this one up. -2 to 5, I'm going to break it apart into two integral using number 3. So where do you think we can break it apart at? So that it's helpful. I want to break the -2 to 5 into two areas.
Could you break it at 0?
At 0, let's see what happens when I break it down at 0, okay? Because it makes more sense if we have small to big, right? So now you can see these two are the same. And they're opposite sign, right? So they can cancel each other out. So you end up with 0 to 5. Okay, so that's your final expression. But it's because I want to make the lower number smaller. That's why it takes an extra step here. But in fact, you can get the same idea if you look at the second line, right? 0 to -2, even though it doesn't make sense, right? And then -2 to 5. These two connect, so you could just look at the beginning and the end, right? The 0 and the 5. So you still end up with 0 to 5. Still works, okay? It's just 0 to -2 looks weird. Right, so that's the idea, okay? You sort of play around with the boundaries and then apply the properties, okay? So I'll let you try question B. Sometimes you break it apart, sometimes you flip them upside down, right? Okay, so if you finish simplifying the question B, you can raise your hand. So your final answer should be just one integral. Please raise your hand if you finished or if you get stuck. Okay, Carrie, can you share with us what you did?
Just my answer or like my work?
Your work, how did you move that around?
So I just I kept like the first one the same.
Okay, so -3 to 6, yeah.
Yeah, and then I switched 10, like integral 10 to 8 and 6 to 8. So I switched places with them. So the 6 is with the first one.
Okay, so 6 to 8, and
Yeah.
then -10 to 8.
For the third one, I flipped it. So it would be plus
Plus
8 to 10.
8 to 10, okay?
Yeah.
Yeah.
So
then
there would be ones that kind of have matching pairs, like the 6 and the 8.
Mm-hmm. Okay, so we have the 6 connects with the 6, and then 8 connects with the 8. Okay, so they all lock into each other, and then?
And then I don't know if I did this right, but I got like -3 to 10.
Yeah. Okay, so that as long as they all connect, right? It's like finding one area, right? And then add another area from left to right. And then it's the same as just getting the whole area, right? Same idea. Okay, very good. So this just to help you, right, to understand or right, be more familiar with the idea of net area, okay, and what integral does. Okay, now just like the derivative, right? Sometimes you get something that's not differentiable, right? Sometimes is you can put a tangent, sometimes you can't. And for integral as well, there are some cases of the function that you cannot find the area, right? So we call that not integrable. So we need to know when it will be integrable and when it's not, right? So over here, it says that the function is integrable on the interval if one of the two conditions are met, okay? Just one of them, okay? So first one, if it's continuous on the interval, then guaranteed to be integrable, right? You are guaranteed to find the net area. Second condition is if the function is piecewise continuous and is bounded. Okay, I'll explain what I mean. Bounded on the interval. Okay, oh, here it already says, right? So if there is no vertical line, vertical asymptotes, because vertical asymptote means the function will go up or go down forever, right? So that's not bounded. Okay, if there's no vertical asymptote, then it is bounded, right? So bounded means no vertical asymptotes. Okay, so let's look at the following ones. Okay, so question A. Okay, is it integrable on A to B?
Yes.
Yeah, that one is continuous, right? So this one, yes. This is continuous. Okay, question B, is it integrable from A to B?
No.
So this one is the one when what we call it the piecewise continuous, even though it's not continuous, right? But then there is no gap between the broken place, right? Even though that this continuous place. So I could find the area from A to C added with the area from C to B. So this one is still yes. Okay, so this gives you an example of a piecewise continuous. Okay, so so we are checking the x values. Okay, so you want to make sure on the x there's no gap. If at C they are both empty circle, then it's not integrable. Okay, but since one is empty, right, the other one is has a dot, then it's integrable, right? And then question C, yes or no?
Yeah.
Yeah, also yes. Okay, this one's continuous, but then the area is part of it is negative, right? Just like the example we saw before. One of them is positive, right? So you get the net of the two. Okay, so this one is because continuous function. Okay, next one, the area, the function is integrable.
Nope.
Nope, this one is no. Okay, so this one, the area keep on going. So we'll never finish finding the area. Same with this one. So this one has an asymptote line, right? So vertical asymptote. Okay, so this one's no. So, but then when you're calculating, like later today, you will be learning formulas. When you are calculating with the formula, you will still find an answer. But if you forget to check the asymptote line, then you will still submit the answer and get it wrong. Okay, so just make sure you want to check within the interval. Is there any place that's undefined? Okay, so if you saw that at the very beginning, then you right away just say undefined. Okay, this question has no answer. All right, so keep that in mind. Okay, very important. Okay, questions, part C now. Okay, so far in part B, okay, let's just quickly recap, right? Part B, we focus on area under the curve, right? Nothing to do with derivative, okay? So that's like a completely new concept, right? Now question C is something connected with what we learned before. It's called the antiderivative. So it's like the underivative, which is in book one, right? Book one is fully focused on derivatives. So we want to undo it, okay? Going backwards. So let's look at the definition here. It says if there is some function, if you prime it, can give you f of x, right? Big F prime give you f of x. Then the f of x is the antiderivative of f, right? Unprime of f, okay? Think about this, okay? Because now we need to twist our head backwards now, okay? And then if we add a constant to that function, then it's called a general antiderivative, okay? So one is adding a constant, the other one did not add a constant. Okay, we'll use an example here. So remember the small f, right, is the after prime, right? Something prime give you f of x. So given the function f of x, can you please find its antiderivative and the general antiderivative? Okay, so you want to unprime this one. Which function primed can give you 4x cubed?
X to the 4.
Yeah, x to the 4, okay? Using the power rule, right? You can easily check by taking the derivative, right? Prime that, give you 4x cubed. So that checks, okay? So this one is the antiderivative, but that's not the only one because I can add any constant. So let's say add a 5, right? Because when you prime the 5, it still give you the same thing, right? Still give you that, right? So there are infinite number of antiderivatives. So the general will be f of x equal to x to the 4 plus c. Okay, so this is called the general antiderivative. Any questions? Okay, so part B, I'll let you try this one. Okay, it'll be pretty easy. If you remember your hexagon, okay, so raise your hand if you got the antiderivative, the general. Question? Anyone has questions?
Wait, but how about the negative?
Which negative?
Because cosine x prime is negative sine x.
Cosine x prime. Oh, you mean prime the cosine will be negative sine x, right?
Yeah.
Yeah, so the cosine is not the antiderivative of that. So what do you?
Oh. No idea.
How do we make it so that when you prime it, it will become positive?
Squared? Oh.
You prime the square,
No, it's already negative. Sorry, never mind.
okay? Emily, what do you think?
I didn't completely think this through, but could you, tentatively speaking, just add a negative sign?
Well, the only thing you can, well, it's pretty easy to check if that works or not by priming it, right? So you say you want to add a negative sign to what? To what?
Just cosine x?
Cosine, okay, so let's think about it, right? if I prime this one now, right? Forget about the question, right? I want to prime this negative cosine. What do you do with the negative? Because negative is like having a constant, like -1, right? If there's a constant in front of it, how do you prime it? Do you need
You
to,
would just
yeah?
pull it to the outside, right?
Yeah, you just stay there, right? And then?
And then you would just prime cosine,
Yes.
I
And
think.
what's the prime of cosine?
Sine x, negative sine x.
Negative sine x. So you see it cancels out, right? You end up with sine x. Okay? And then for the general, then you need to add a c to it. Okay? So remember to add c to your function. Okay? So this part is just for checking, see if it works. Okay? Right. So if you know how to do derivative, then you should be able to get the antiderivative, right? You just think backwards. Think about what was the formula when you prime can give you that, right? And remember the exponential and ln, okay? Don't forget those 4 formulas, okay? Right, so next part, does anyone have questions here? Am I going too fast? Okay, so here is a table of antiderivative, but this is not a new thing, okay? This is something new because it's the backwards of derivative, right? So one of them, right, if you, like for example, this, look at the right-hand side, okay? Look at the antiderivative. So if you want to go from antiderivative to here, you need to prime, right? So let's take a look at the right side, right? C big F, if you prime that, it will become C small f, right? Because big F prime will give you small f, right? So same thing with number 2, right? Capital F, capital G prime become small f, small g, okay? Now for the third one, let's actually prove that one, okay? Or check that one, okay? So if I have x to the n plus 1 over n plus 1, n is a number, right? And I want to prime that. You can use the power rule, okay? Power rule tells us to bring the exponent down, right? So exponent to down, and then exponent minus 1, so that will give you n plus 1, right? And then n plus 1 will cancel out, you get x to the n. So what's the use of that, okay? Usually is you want to find the antiderivative. Let's say antiderivative is, the function is x to the 7, and I want to find, okay, I should keep the symbol the same. Okay, I'll use f, small f. F of x is x to the 7, and I want to find big F. Then you follow the formula, take the exponent plus 1, and then divide by that. Okay, plus c. So that's your general. Any questions so far? Okay, so
Wait, can you re-explain the left side again, please? Like, I'm a little bit confused now.
mean this part?
Yeah.
Yeah, okay. The left side is just checking if the formula works or not, okay? So if you prime the antiderivative, it will give you the function. Make sense?
Yeah.
Okay. You prime the yellow highlighted part, it will give you the original function. So we are just checking if this antiderivative works or not. So,
Oh, okay.
so what I did is I just prime it using the power rule. So I bring down the exponent to the front. So your red exponent goes to the coefficient. Okay. And then the exponent minus 1. So that will give you the n, which is the green one. Got it?
Yeah.
Yeah. And then that coefficient will cancel with the denominator. and that's x to the n. So it shows you the left side,
Oh, okay.
right? The x to the n.
Thank
Okay.
you.
Yeah. And then, but then usually the question is they will give you the small f, ask you to find the general, right? Ask you to find antiderivative. Question is to go this direction, right? Going to the right side. So that's why if you see x to the 7, right, then you need to add a 1, become 8, and then put an 8 at the bottom. And you can double check, right? Prime this, then will be 8x to the 7 over 8 plus 0, so that gives you x to the 7. Understand now? Yeah? Okay, so now look at question on number 4 now, okay? So if you remember long x prime will give you 1 over x, right? That's one of the formula that we learn in exponential, right? And then also e to the x, doesn't matter how many times you prime, it will be the same. But that's if it's x, right? If it's not x, inside you need to use chain rule. And number 6 is what we just did above, right? It has to be negative cosine, right? To be antiderivative. And sine prime, give you cosine, right? Sine prime. Tangent prime is secant squared. So go back, right? Go back is tangent, right? Cosine, antiderivative is sine. Same with this, okay? So look at arrow. Look at the arrow both ways, okay? Make sure you don't confuse. But I'm sure you should be fine, okay? Because we spend like, I think 75% of the time doing derivative, okay? So probably it won't mix up, okay? All right, so let's try a couple questions to get the antiderivative. So they will give you the f, right? The after prime. And we want to go back, find the antiderivative. A function that prime can give you small f. Okay, so I'll show you the first one. So this one, right? Usually we want to rewrite this first. So we can rewrite this 3 over, just like when we try to prime, right? We want to rewrite it. So then it's easier to apply the formula. So this one, we can write it as 3x to negative 2 minus 5x to negative 4. Okay, and then if you look at the table here, right? Number 1, it says, right now we're doing the red, okay? We're going backwards, right? Getting antiderivative. So number 1 says if there's a constant, it stays there, right? I can ignore it. All right, and then if the function, now look at number 3. If the function has an exponent, I do exponent plus 1 and then divide by that. All right, so let's do that. So big F, there's a constant, right? Constant of 3, so stay there. Now there's an exponent, so I'm going to do exponent plus 1. So what's that? What's exponent plus 1? What do you get? Anyone? Negative 1, right?
1.
Yeah, and then I take that same exponent, divide by negative 1. To make it easier, I just put negative at the front, the same thing. Does anyone have question here so far? Okay, next term, do the same thing. The constant stay there, so negative 5. Exponent add 1, divide by that. So Leon, what do you get?
Wait, wouldn't it be plus 5x negative 3?
Plus 5x, you have to divide by 3.
Oh, right.
Right?
Okay.
You got to divide by the same number, right? So you add 1, it becomes negative 3, and then you divide by negative 3, and then that negative makes it positive. Make sense, Leon?
Yeah.
Yeah, okay. But do not leave the answer like that, okay? We need to add a C. This is general, right? And then put your answer back into no negative exponent. So negative 3 over x plus y over 3x cubed plus c. Okay, so leave your answer like this. So that's your general antiderivative. All right, so this is using that table. So please try question B and C and both of them, okay? So raise your hand when you finished.
Wait, Jason.
Yep,
For C, it says f of theta.
yep,
So for this one, is theta? Wait, theta is a constant already, right?
variable. Theta is,
Oh.
yeah,
Oh, okay. Sorry. Thank you.
like x.
Oh, yeah. I see.
Whatever you see after the f, right, the symbol, that's always the variable, independent variable,
Okay.
okay?
Thank you.
Yeah. Please raise your hand if you finish both. And leave your answer with positive exponent and radical if there's any radicals needed. Okay, let's check answer for B first. Lex, can you tell us your answer for B?
It's for negative x,
Negative x.
negative cosine x.
Oh, okay, hold on. Let me change it. So that will be negative 4 cosine x. Then you put negative, yeah,
Minus x to the power of 6 over 3.
over 3
Yeah, I'm not sure if this is right, but and then it's 24x
plus 24x
fourth root, and inside it's x to the power of 3, and on the bottom it's 7 plus, like, over 7.
over 7. Sorry, I can't hear you.
plus C, like general, right?
Like that? Is it? Huh, Lex? Is that what you meant?
Yes.
Yeah?
Can you hear me? Yeah.
Yeah, okay, okay.
Wait, I got something different.
Okay, what do you have?
I have the same like -4 cos x, and then I got minus x to the 6 over 2.
And then?
Right? And then plus 24x to the 7 over 4 over 7 plus c.
Okay, all right. So, well, if you want to check this, right, easiest way is to prime it again. Because you guys know how to prime now, right? So you prime it, see if you get the same thing back. Okay, so yeah, so let's double check. Okay, so for the first one, right, you can rewrite it as the third term. You can write it as 6x to the 3 over 4. Right, write it as 3 over 4 first. Okay, so let's check this answer. So I think the first term everybody got it, right? Sine on prime is negative cosine. So that one's everyone's good. Okay. And then the next term is you need to add an exponent by 1. So that will give you 6. And then divide by 6. So it will be 3 over 6. Right? 3 over 6. That will give you 1/2. Okay. So far it should be this one, right? And then x to 3 over 4. So you same thing, you take the exponent added by 1. Added by 1 will become 7 over 4. And then you divide by 7 over 4. When you divide by 7 over 4, it's like times it by 4 over 7. You need a reciprocal, right? So it will be 6 times 4 over 7. Okay, let me write it down, okay? Write out the steps. So the big F, okay, the first two terms are okay now. It'll be 6 times 4 over 7 x to 7 over 4. Okay, because you divide by 7 over 4, you need to flip it. Okay, and that will give you the third term. Okay, but then we prefer to leave the answer in radical. Okay, so your answer should write it as 4th root x to 7. Okay, plus c. So this one. Okay, very close. Okay, and then now for this one, actually the third term, right, for Lex is the same. Okay, I think she just took out the x, right? So it's the same. Okay, so for her is the only problem is the middle term, right? This one is the same as that. Okay, very good. Okay, question C. Joan, what do you have?
I got theta squared over 2
Yeah,
plus secant theta.
yeah. Any more?
That's it, I
That's
think.
it. Are we missing anything?
Oh, plus C, sorry.
Okay, very good. Okay, so yeah, so remember to add a C. That's if they ask for general antiderivative. If they just say give me any antiderivative, then you can add anything, right? You could add 0, right? Okay, so that's correct. Does anyone have question here? Okay, so that's our general antiderivative. Okay, now here question 8 is they give you some conditions. Okay, the condition is like a point on the function of the graph. Okay, and then also look at the symbol that they use. Instead of giving you f to start, they give you f prime to start. Okay, so this one is still the after, right? Because they already primed. Same with the question we had before. This one is also after. So instead of separating after and before by using small f and big F. Here we just use small f all the time, okay? So if after is f prime, then before, I don't need to use capital F now. I could just use the without a prime symbol, right? So that's why it says, please find f of x. So this one is the before, right? Same as the capital F we had before. Any questions? Okay, just different ways to ask the same question, okay? And then they give you a condition, right? So this one is the condition. So this condition is to use to find the constant, right? Because with different constant, you get different function, right? If you add a 1, add a 5, right? It's kind of like doing the vertical translation of the function, okay? So having a point there, it fix the function, okay? Fix to one of them. Question A is pretty easy. I'm just gonna go straight to B now, okay? So B, you have a double prime. So that means when you find the antiderivative, you got to do it 2 times. Okay, on prime, anti-prime 2 times. Okay, so you do 1 time first. After the first antiderivative, you get f prime. From there, you antiderivative again, then you can get the f. Okay, I'll let you try this out. And then you can raise your hand when you feel that you got stuck, okay? And then I can go over it. Or if you finished, okay? Just go as far as you can. The conditions there are for you to sub it in to find the missing constant, right? Okay, I want to check the first prime first. Okay, Jeffy, do you have the first prime?
Give me a couple more seconds.
Okay.
Because I have everything except for the f prime of 0 equals 2. So I have everything up until that.
Okay.
Which is -3 bracket cosine x plus 2e to the power of x.
Plus,
That's what I'm figuring out right now.
okay. Need to have a constant plus c. Okay, if I unprime this one again, right? Unprime the f prime. Then what would it look like? Nicole?
Jason, the c is plus 8.
Okay, c is plus 8. I'll write it on the side. C is 8. Okay, Nicole, if you unprime the first prime, what does it look like?
Wait, Jason.
Yes, Jesse.
My first C was 3,
It's
not
C.
A.
Okay. Yeah. That's
Because
right on the side. I'm not sure. Yeah.
Okay.
But right now we could just consider it's constant. We'll find out the constant afterwards. Okay, Nicole, do you know how to get the prime? Because I can't hear you. Is your mic working, Nicole?
Hello, can you hear me?
Yeah, I can hear you now. Okay, so what's the antiderivative of -3 cosine x?
It should turn something like into 3 sine x.
-3 sine x. Yeah,
Um,
plus, what's the next term then?
like 2ex or something.
Yeah, 2e to the x, right? E to the x, you can check by priming it, right? E to the x prime is still e to the x. Okay, next one. Okay, let me ask Emily, what about the antiderivative of c? The constant. What prime can give you constant?
The if you just tacked on like an x.
Okay, so cx, right?
Yeah.
Yeah, okay. So if you prime cx, it will give you c, right? And then you need to add another constant. Of course, it will be a different constant, so let's call that d. Okay, so when you begin this question, you just unprime each one. Each time when you unprime, you get an extra constant. And then now you can use the condition that they give you to find the missing constant. So the first one, f of 0 equal to 1, you put it into, right, the f of x, okay? And then the second condition, the prime one, right, prime at 0, you put it into the prime one, okay? So you can find the c and d.
Jason,
Yes,
E
Jeffy?
should be 3. I multiplied by 2e instead of add.
Okay.
Should be 3.
Okay, so it should be 3. All right, so if you finish C and D, I mean, if you finish finding C and D, let me know. Yeah, Jesse? Yeah.
For f of x, I got positive 3 sine x.
+3.
Because yeah, because if you do the antiderivative again, it's another negative, right?
Is it?
Oh shoot, my bad. No, it's still negative.
Yeah.
Yeah.
You
Never
could
mind.
prime it, right? To check.
Yeah. Oh, and then my C was 3x or 3.
And D?
I got -1.
-1. Okay, anyone got different? C and D? Okay, please raise your hand if you found both C and D. Okay, Joan, what do you have for C and D?
I got the same thing.
Same thing? Okay.
Jason, I have a question.
Yep.
How come when you unprime C, it gives CX?
Because think about, let's say if I have y equal to 7x, what's the prime?
X to
Prime. I'm asking.
oh prime
Yeah.
just 7.
7, right? So if your prime is a constant, you want to go back. You want to go back, right? On prime, you just add an x.
Oh, okay.
Make sense? Right? We want to go back on prime it.
I got it.
Yeah. Okay, so anyone else didn't get the C and D? should be 3 and -1. Okay, we'll be having an early break today. Okay, so then we can move on to the new topic. Okay, so right now it's 6:07. Let's start at 6:20. Okay, and if you have questions, you can stay during the break.
Thank you.
Okay, 6:20.
Thanks, Jason.
Yep, you're welcome. Bye bye. See you soon.